Alright, welcome everyone. How are we doing? Okay. Just get set up. How's it going, Ransel? Welcome, welcome. On Friday, the festival starts. Fantastic. So is it like a weekend long thing? What are we doing? So I want to open up the shader file. Right, so last stream, we started working on... Oh, we got clipping working. That was so good. So we got SDF based clipping, and we did some... yeah, we did SDF based clipping and optimization, maybe. Yes. I think that was last stream. So we got it down from 1.3 ms, this test scene, down to about 0.9 ms. I think that was this stream. Or last stream rather. So this stream we're going to be working on transforms. We did start working on them last stream as well. But we're going to think about what we've gone and started and think about the possible things we want to, the routes we could take, because it gets a bit complicated. Well, sorry, there's pros and cons to the different routes we can take, basically. So yeah, so we might disable. For Vulkan play music, nice, fantastic. You're gonna be tired, a tired man. Right. So how the crap are we gonna do this? So what we've got. So it gets a bit strange here, you see. Crimson Mania, how you doing? Good to see you. So should we disable Mickey Mouse? Should we get rid of Mickey? So the Mickey Mouse clipping is now gone for a second. So we've got all these beautiful shapes that we're drawing. Each one of these is a draw command. And we want to add the ability to be able to like transform these things. And I guess there's two routes we could take. So we've already started it, but yeah. What changed? The shapes? I think I put a background on it. And then, but yeah, have you seen my Mickey Mouse? You seen my Mickey Mouse based clipping? So we can add custom clip shapes purely made out of sign distance fields. And you can color it, so you can color the alphas, so alpha blends on the solid parts. So we've made it like a bordered, it's alphaed on the border by about half, so it gives it a nice little edge to it. There's my Mickey Mouse. See around the edge, it's sort of like half transparent. And then you can also animate it, and you get yourself a. It's fantastic. Anyways, so there's Mickey Mouse. So let's disable the clipping now. How do you get it? Oh, you're golden. Oh, you're talking about the emote. Golden Kappa. Ah, I see. Probably someone's special channel one, right? Right, so transforms. We want to have the ability to transform things. So we currently only have two shapes. We probably should add more before we finish this renderer. But we've only got an axis line bounding box and a circle. So as you can see, these are all made from axis line bounding boxes and circles, right? Two circles here and a box. Now, the thing that would be cool is like, so this is one draw command comprised of three shapes, which then get joined together and then colored in via a gradient. So what I want to try and do is like, I would prefer if we could just rotate individual elements, right? Because then you can rotate the axis line bounding blocks. That'd be great, right? But then, so we've got to see if that's possible with the way the current thing is set up. And if it's not possible, then the only thing that we can do other than that is to rotate the entire draw command, which might not be good though. So yeah, I'm a bit... Yeah. Because if we look at the sign distance field shapes that we can get... a lot of them... See, these are boxes. It's orientated box. So we could make it... We could just have an orientated box anyway. There's ways of doing it. We could rotate P basically, I think. Yeah, rotate P, because P is a point relative from the center, origin 0, 0. So we could rotate point P, and that'll work. So maybe that's the way we do it, right? So the problem... So I added some new guys in, right? I added op scale, rotate, op translate, and op skew. Ah, hype trains. To get that thing. Fair play. And you only keep it for 24 hours? That's crazy. I thought they were like, just give it to you. Can you P is a point, not a direction. So it wouldn't be capable of... Yeah, well, technically it's a point. But you can think of it as a vector, P, and you just be able to rotate P. Just treat it as a vector and rotate it. Should be fun. It's a point relative from, points is relative from the origin, and in this case, origin 0, 0, so rotating it around the middle should just be fine. And that means we can do it on any shape. The circle wouldn't really be useful, obviously. But any of these guys, if we decide to add these in, right? So the thing is, the way the system works is you have a draw command, and it has a bunch of like little operations that happen one after the other, and then you say finish. So if we say something like, this one here, it says, we've got 3 circles and we subtract them all from each other. So it's like that circle, take that circle, basically. Right. And then we say this is the color, it's got a border, right, and a solid and a inner color, and then we say finish. Yeah, maths, it goes over my head too sometimes. It only... Yeah. Like, it's so easy to forget about things because maths is, there's just so much, and you just especially when you're tired as well, maths don't go well. So we've got a bunch of these little operations that run after one another. So if so in the shader, we have this thing called a coordinate. And this is our pixel that we're rendering. So if we take the pixel that we're rendering, and I was rotating it, you see. When I came across one of these rotates that we put in. Ooh. Yeah, so we've got a rotate here. I started ray tracing in a weekend stuff the other day. I have no clue, lol. Don't worry, you got this. Just keep trying it. And reading stuff and you'll pick it up. Yeah, so we've got this coordinate, this pixel coordinate. This is one that we're sampling. This is the one we're sort of using to see if we're inside any of the operations. So when we say a shape, we've got this sort of circle that's at this coordinate and it's this big. We check to see if the point is inside there, basically, or if it's got, what's the distance from the edge, and if it's negative, it's inside, right? That sort of thing. So if we were to perform a rotate, right? Let's just imagine this. If we were to perform a rotate, should it rotate just the next shape, or should it just set a general rotation? And then whenever you do a shape, what it will do is when it does the circle, right? See here how it does this difference? Well, it should rotate that, right? And then if it rotates that, there's no state that's being left. Like, we're not modifying this coordinate, because that's what I was doing before, is I was modifying this coordinate. And then that would mean it would infect everything else after it and all those things. But if we can apply rotation to anything, like a stack of rotations. Yeah, the problem is if I say rotate, yeah, I'm not sure if it'll be like a stack of rotations. It might just be it sets like a rotate register, and it you're just setting that, and everything after just uses that rotate, and it rotates it around the center of the shape that you're trying to draw. So you can set it and then change it back. But then, like, say if you have scale. Hey, not so red, how you doing? Welcome. Scale allows you to do a non-uniform scale across the X and Y axis. So it accepts essentially two parameters in a way. So if we were to set this into like a scale register, right, and then it will sort of like change the coordinate, the relative coordinate from the middle, and scale that, right? That works. See, it's as if like you need like a matrix. Yeah, something like, oh, you mean like a stack like that? Yeah, we could have a stack like that. Yeah, obviously rotating a circle doesn't do anything as well. This is a really bad example. But yeah, scaling a circle would do something, because then you can get the non-uniform scale on the circle. Which would be pretty cool. And then it will work for everything that comes after it, which is interesting. And you can always pop it back. Yeah, still kind of the transform thing. I didn't get to... Yeah, I work on everything 100% on stream, so we finished up last time on the transform. And then I realized how bad the version is for the one that we currently do, because the current one that we do is we change the sample point. We change the coordinate itself. But then the problem is like if we draw two boxes, we just get the drawing tool out. Well, that's the thing. It's like you could rotate it. It's scale, rotate, transform, isn't it? SRT. So when you scale it, it might not be a circle, so the rotate would then work, wouldn't it? So yeah, that's true. That does work. So the problem is like, say if you have like a couple of boxes that you're drawing, in one draw command for some reason. So that'll have this sort of bounding box, right? Now, when I tell it to rotate, okay, technically it's here, but anyway, whatever. When I tell this one to rotate, it's going to rotate it around its center, right? But it's not going to rotate this whole draw command around, right? Whereas if I did it the way that we was going to do it before, it would rotate around the center of this bounding box. And also thinking about it as well, is by rotating these objects, they would, and scaling, they would mess with the bounding box. And we need the bounding box because that's how we texture it. We take the bounding box, or say we have this point, well, here's the bounding box. We just map that to the UV coordinates of here and here, right? We just map it like the bounding box is the UV, as a UV min and max. Put that, for all the texture, and we just sort of remap this point into that texture space and sample it out, Yeah, I know about moving it back to the middle. That's fine. I'm moving it back to here. Rotate, move it back. So I guess the question is for these scaling operations, is it okay if the scaling operations are for the shapes and not for the draw command as a whole? Right? Well, because also if you rotate the box and you've now changed the bounding box, right? So you have to do that rotate code, like, because this could be bigger across on different dimensions, right? Therefore, the bounding box has got to expand. Provod, welcome. Thank you for the raid, really appreciate it. How did the stream go? We're currently working on a 2D sign distance field renderer for UI, so we're just doing some big test scene here. We're using nothing but compute shaders. So we're just trying to figure out how to add transforms to it. We've nearly finished it, so we're just wrapping up on one of the last few features. Yeah, welcome to stream, guys. If anyone has any questions about what we're working on today, feel free to ask away. Or just about the project in general. Hey there, Indifferent. Welcome. So we're currently trying to transform either a shape from what's... So each one of these guys here is a draw command, and you basically have a list of operations that happen in a row, and that comprises a single shape. So this one has got an operation of a circle, another circle, and a box. And then it's got a union, a smooth union, so it's able to do smoothing between them all. And then it's got a color operation to do a smooth gradient, like a linear gradient. So that's how we're drawing that shape. So we're trying to figure out whether if we add transforms, do we transform the individual shapes that you place down, or do you transform the entire draw command with all the shapes in it? That is the question. We did some bug fixes. Nothing super interesting. That's cool. Yeah. But it's always great when you have the bugs fixed, because you get far less issues. But yeah, awesome. Good, nevertheless. Akraz, welcome. How you doing? How you been? Welcome, the lazy fish. Welcome. Yeah. So yeah, I was thinking if we rotate the actual individual components. So it's imagine if we have some editor which allows you to make your own draw, you know, like superset of shape. What's the way of saying it? A group, one draw command, which is comprised of many shapes, and you have some form of editor where you like, I'm dragging a box over and I put it down. I want to rotate it, right? I think it's more. I think it makes more sense from a point of view when you're building some complex sort of like draw command to be able to rotate the individual objects around their center and place them in, right? I think that makes more sense. So I think we'll do it like that maybe. This SDF word up at the transform is literally what I've been thinking about the past week in background context. I'm making a secret professional 3D SDF editor for demo scene purposes. Oh yeah. Yeah, SDFs are really cool, and they're really flexible, and also it's a really cool project. It's great because because obviously Dreams has now been like cancelled, so, and that's only on PlayStation. So it's good to see that people are doing this SDF stuff. I think there's some other projects as well someone is doing. But yeah, they're really fun, and they're not triangles, because triangles are just the worst. And SDFs are like super powerful. You can make some really interesting things with them. Yeah, that's what we're doing with this 2D UI, is like having the ability to like make these vector graphics so we can like just scale and have like an icon that's just purely made up of this stuff. And obviously if it becomes too expensive, we can probably bake individual items, but for the most part we'll probably just suffer with the hit on performance, Yeah. But we're gonna try and optimize it as much as possible. We just spent ages looking at. We just spent we spent like half a stream literally optimizing it down to like looking at the stats from the AMD driver and just really trying to change, reduce some numbers basically. So it's really cool. The hexagon is the bestagon. Yeah, there's no hexagons just yet. Don't you? But yeah, big fan of SDFs. Big fan. So I think we should rotate the shape. Now, we come in here and we go rotate by this many radians, right? And then you probably have to reset the state back again, which just feels really dodgy. And also you're increasing the amount of words you're chucking in to that word into that word array, and this probably there's more things you have to switch on in a shader, and it just gets a bit crazy. So, and also another thing as well is like you have scale, rotate, translate, and skew. That's another thing. So if you rotate, yes, obviously then translate basically becomes, well, it doesn't really become pointless, because you can say if it's infectious, right? Just as a you could just change this like an offset to everything that's rendered in here as an example. Or it's kind of after the scale as well. That's another way of thinking about it. Yeah, if it's like a little. But yeah, say if you want to like scale it, then like maybe like a non-uniform scale or something, whatever. And then you rotate. I mean, you want to reset that state back. It gets like proper bad. So you're filling up with a lot. So, but a full 2x3 matrix for 2D, which comprises all of them, is six floats. Right. So you could probably squash that down into maybe 3 floats. Right, well, 3 integers that you then reinterpret as 6 floats. Right, and so you could just say, like, we can actually just put in a transform instead. So you do a 2x3 transform or something like that. The read temple that Indigo made from just... Oh, sorry, Ingo made from 3D SDFs was pretty sick. Yeah, there's so many incredible things with SDFs. Like, yeah, temple was cool too. Yeah. Just an absolute madman. So then if we update a little matrix every time you want to change it, and then you just apply it to your point, that also just sounds really bad as well. Like, we could definitely pack it down. No, we actually have a bounding box. So say if you say, like, hey, say if you put these 3 circles down, right? And then while you're putting those 3 circles down, what it's doing is mapping out a bounding box. And then when you say finish, it pokes in the bounding box into the start of the draw command. So on the GPU, when we render these things, when you want to texture them and all that good stuff, it can use the bounding box. Basically. AABB. Yeah, there's access line bounding box. But yeah. So scale, rotate, translate. So you could probably remove translate. So we remove translate, and that leaves us with scale and rotate, which means all you need is a 2x2 matrix. Right, and with a 2x2 matrix, you can do... Can you do skewing? You can, isn't it? Skewing's... yes. So all we need is a 2x2 matrix. So that means every single time... Right. No. Every single time. Every single time we do this, right? When we say draw shape, we just do a min-max on the... Yeah, so min-max on the bounding box, basically. Right. And we build the bounding box when we build the commands. The draw command, right? So the issue is when we start applying the transforms, we have to account for that in this as well. Go. Is that understandable? So we could do a little matrix, 2x2 matrix. So that's 4 floats. You can pack it down into we could pack it down into 4 float 16s, right? That we sort of just pack into two 32-bit integers, and then unpack it when we get it. So then that's kind of small then, isn't it? Right, so then that's basically the size of a scale. That would have been a scale anyway. So if we say UI draw scale, and then say UI draw rotate, that only works on the current shape, and then it will reset it. So when it goes to draw the current shape, it will be like, is there any new transform data? Oh, there is. Quickly put in a transform draw type, and then it'll update the transform. But then, like, essentially it's going to have, like, insert a transform guy here. Oh, no, not different. Yeah, for just... Misunderstood, I thought you were talking about having separate bounding boxes for different groups of shapes. No, there's only a box for per draw command. So you just hit the transform here, but then you'd have to kind of return it back to identity transform after you've done any shape. Which probably can be a bit silly if you keep setting it all the time. I'm not sure how that would be for performance, really, if you keep setting that all the time. But maybe you could restore it back to identity manually. But then that's another switch statement to process, right? But then again, every shape could just take a transform, right? And if every shape takes a transform, that could be, again, 2 integers, and then you just you unpack it every time and then use that. Oh, so yeah, the transform idea could work. Well, where the little transform that gets passed up, that little 2x2 matrix. So the other thing is as well is if you sort of like, would you ever want to transform the whole? So you're more likely to say, well, I've got this thing I want to move into here, and then transform that individual item, that individual shape. But say if you got the group of shapes, and you want to rotate all of those guys, and scale all of those guys together. How would you do that? Hey J Ty, how you doing? Welcome, welcome. Well, for that one you could apply it to the whole draw, I guess. You can scale and rotate the whole draw. This is a lot of features, and I'm just thinking about the performance here. This is really bad. Now, we've now convinced ourselves that every shape gets a transform, but then you can also apply a transform to the whole draw. So maybe that will just rotate the whole coordinate. The coordinate that you're sampling around the center of this guy, or something like that. I'll take it back to origin 0, 0, meaning this, and then it'll sort of rotate it around origin, or scale it around origin, or translate it around origin, and then translate it back. So that means every draw command could, as well as having a bounding box, be given a scale rotate, just another 2x2 matrix, and then you apply it to the coordinate. You see, we can test what it's like for performance very easily without doing anything. So what we're going to do is we'll have one matrix. Yeah. So we'll get some performance data right now, and we'll see what it is like. So we're about 0.6 ms right now. So what we're going to do is we're going to add a matrix that goes in at the start of every shape, and a matrix that goes in at the start of every draw, apply it to both of them, and then see how it works, right? So at the start of every draw, let's push on 4 words for a little, well, I wanted to do 2 words, wasn't it? And pack it down, and then unpack it. I don't know if that's a really good idea. I should do 4 words and see how it is first, and see how bad the forms could be. So let's say we get our floats. And then you say like matrix 0. Yeah. So you just need a 2x2 matrix for rotation and scaling, right? It's got to get this right. So you'd have like an angle. Well, we could make this one just be identity, right? They could always just be identity, I think, anyway. So identity would be 0, then 2 will be 1. Something like that. And then we want to also throw in, at the start of every shape, let's say at the start of a circle, we push in another identity matrix and another identity matrix. And then we need to do that for the clip shape as well. Shoot. Alright, let's try this out. So remember, at 0.6 ms, that's what we're on. So put 4 words in there, identity, identity. Okay. So if we compile that, let's go over to the shader. Now we just want to pull out a matrix and then apply a transform to things. So what are we doing? So at the start of the command after the bounding box, there's 2 more words to pull out. There's like a matrix. So you want to read this as like a 2x2 matrix. So you say matrix. Plus 4. One, 2, and 3. So I want to do the same thing. Do we need to do the same thing for the clip as well? Like, oh, I think it's a clip matrix too, damn it. I'm really not sure what I want to do with this thing. Clip matrix. So this would be like clip matrix. Uh, 0, 1. Sorry, 0, 0, 0, 1, 1, 0, 1, 1. Very nice. Add to the clip words, because you should be extracting from the clip word. Right. Ugh, this is the clip words array. Because we added that to the clip words as well, yeah. So the clip would also be able to do this transform too as well. Right. So what we want to be able to do is when we take the shape and the circle out as well. Sorry, the circle and the box, wherever that one is. Here we go. So we also want to be able to pull out the matrix here as well. So I put it at the start, wasn't it? So it's in words, word index. So this is like shape matrix, something like that, right? So what we want to be able to do is apply this matrix, right? So I completely forgot how you do this. It all depends on the major as well, isn't it? So I guess let's just see how much of performance it adds when we just add it into the buffer, but we don't actually use it. So we was at 0.6 ms. So let's see what happens when we run it. Please don't crash. Right, so that appears to have not added anything, believe it or not. Basically no extra performance for that. Now let's start to actually do some multipliers. I guess it's maybe like just incremented an integer and skipped over it because of the optimizer. But let's see what happens when we actually try and use these things. So how do we do a matrix multiply? What do we do? So let's say we got your vector. Let's just imagine we've got this vector. You've got a 2 by 2 matrix. So let's say it's like column major. Column major, which then would mean shape matrix like, so we're trying to do, so V or E relative from that, we just need to scale and rotate, right? So 2 by 2. That would mean shape matrix 0, 0, 0 will contain, and 0, 1. So if it's column major, let's think about the order. Yeah, so the vector will be in that, right? That's your vector. Is that right? Well, it depends how these are read into as well, isn't it? No, that's fine. Yeah, that's fine. So 0, 0 and 1 will contain the first column. So this is column row. Perfect. So, I always get so confused with these things. So it stores these guys linear in memory, right? But then you have your vector. Yeah, so your vectors sit like this, basically x, y, x, y, or something like that. I'm pretty sure. So this would be x, x. Let's have a gander. Let's have a gander. Yeah, it's just so bloody confusing because the mass notation is column, but then it's honestly it always fries my damn brain doing this stuff. It's so silly. See, then people say, "Hey there, Lucy in the sky, welcome. How you doing?" What am I trying to do? Maths. I'm just trying to do a 2x2 matrix multiplier, so I'm just trying to figure out the exact places they go in and what indices I'm using for what, basically. You know, based on my column and row major. So what's a sparse matrix? I've not heard of it. So row. Yeah. No, this feels wrong. Well, it's just I've seen many good diagrams. These are all. Yeah, I will need a matrix multiplication, but I think I know how to do matrix multiplication. It's just figuring out the column and row major ordering. You know, it probably doesn't matter. I probably just have to do one because it's just a test example, isn't it? So let's say my vector is, yeah, I might accidentally just end up doing row major accidentally, but right, let's say my vector's here. I'm doing vector times matrix, aren't I? I think someone taught me you can do something like, there's a way you can do it. I think it was, so this is your matrix multiplied by, and there's I forgot how they did it, what syntax they used, but something like this. Does this times this equal... There's one... Don't think they had these on it. Probably what it was. So here's your vector, and then here's your matrix. So you're saying like this, so it's M00 times Vx. And then 0, 1 times Vy. And then there's a plus in between there. And that is what your new x would be. So it's like that one times that one plus that one times that one gives you this one here. So that'd be 1. Wait, yeah. Then this one's the same. It's that one times that one plus that one times that one, which then gives you 1. Ta-da! Maths. I swear I'm not good at maths. So it'll be something like that, right? I'm not sure why. Ta-da! So we want to be applying this everywhere. Let's switch on a light. A sparse matrix is a matrix that has many empty elements, essentially 0, with a few compared to matrix. That's pretty sweet. I never knew such thing existed. Do you like... Which is a number of 0 elements, which... Huh. Right. Right, so it's a way of... Right, that's cool. It's a way, it's like compression, isn't it? Basically. Nice. Ooh. Right, so I think we should be able to do something like... So if we want to just have a quick way of multiplying. So this is our coordinate. Right, so we basically want to like say, right, diff, like that. So should we see if we didn't like absolutely fudge everything? So we'll say diff equal absolute diff. F30 times 2. Yeah, it got super dark quick. That sun dropped. Dropped hard. So that'll just go here like that. Right. So hopefully it didn't break the circles. Let's see. Right, so all the circles just got broken, so something is clearly wrong. So I thought we uploaded 1, 0. Oh, that's wrong. It should be 1, 0, because it's like this, isn't it? Right, so it should be diagonal, right? So that's cool. It's kind of working, I guess. So let's look for matrix. So remember, 0.6 ms is what we're aiming for. When we do all these matrix multiplies, what do we get? Do we get something comparable? And if we do, we're going to put matrices on everything. because the performance says it's fine. But if it isn't, then we'll just won't do that. We'll obviously cut back on the features. So see, right, so the circles are still there. So within the matrix multiply, right? For some reason it says it's quicker. I don't know why this is. Have we accidentally aligned stuff? Yeah, exactly. Yep, that's correct. Yeah, it's row major. Whoops. Yeah, it's cool. It doesn't really matter. I don't have to be anal about my majorness. As long if it works, that's good. Just brush your hands off and off you go. Right. So now that's done on the circle. Let's get it done on the boxes. So we've been doing that as well. So we've brought in. I really don't know why this would be faster. It must be because it's able to optimize and do more vector 4 fetches efficiently. I don't know. Right, so there is another diff based thing, so I've pulled that in now. Let's see what the performance is. And again, we can probably just undo our changes and then just compare it. We can stash them. Right, so that went to about 0.6 there, and the boxes are still here. These axis line bounding boxes are still here, so that's fine. Now the last one we wanted to add in was so we need to be able to translate back to the center of the bounding box. So remember, we've got our circles or whatever which comprise a shape, and we're adding another, well, we're thinking about adding another transform, not just for the shapes, but transform actually for the draw command as a whole. So you can transform all the shapes in one go, you can stretch them, skew them. So there's two different types of transforms. So how about, let's see how bad performance is for this. So what this is going to do before we do anything is it's going to, when you run the draw command, you get the coordinate. So you get the coordinate. Where's the bugger? So yeah, we run this loop twice, once for clipping and once for not whatever, right? So once for clipping, once for doing actual shapes. So this is going to be probably, you call it transformed coordinate. Very descriptive name. So it's equal to coordinate. Then you apply the transform. So there's a clip matrix, there's a if II, that means clip for clipping. So we kind of want to bring the coordinate back to the origin. That's not origin. This is the wrong one. Something like this. Bring it back to 0, 0. So we're saying, yeah, and then you want to apply your matrix. Damn straight. Transformed coordinate. Bum, bum, bum. So bring it back between, you know, where this box, where basically the center of this box is now 0, 0. So then if we have a point, we can sort of rotate it, we can stretch it and all of that. So we're bringing that back here with this line here based on this offset. So it's bottom, it's basically the middle position take that away from our current coordinate. And then we're saying, so we iterate over twice. One is for clipping, one is for actually doing draw matrix, we'll call that. Okay. So clip matrix. And they'll be applying to transformed coordinate. Cool. And then we're applying draw matrix. All right. So this is the final thing to test about speed. So see how speed would go with this one. And then we can also have a play then with these matrices and see if they work as well. So wait a minute. That one. So that puts it back. Right, so we're still at about 0.6 ms. So I don't think we actually decrease performance by adding these matrices in at all, which would be weird. Hey there, Psychode, how you doing? How's it going? So yeah, we've been trying to figure out how do we do transforms, and we broke it down into the fact that we basically, imagine if we had have like an editor. Welcome, I am Kept Payne. Imagine if we have like an editor, and we want to make our own draw command, which is comprised of like the shapes that we want. Well, you want to be able to drag like a bounding box, rotate it, scale it, skew it, whatever. But then also, you might have drawn something like a really complex button that you've made for some reason, and then you want to like rotate that whole thing. There's actually two different kinds of transforms. And I was sitting here thinking for a moment that, you know, I might have to pick one because of performance, but we've just literally added in matrices. And by the looks of it, it's not like we've done a 2x2 matrix, right? So we've got rid of translate because translate's basically useless. Well, it's not useless, it's just, yeah, it's 2 extra floats and it's like, eh. So we have a 2x2 that does scaling, rotating, and skewing, all in 4 floats. And I pack them in, one per draw command, and one per, oh yeah, local and world space, exactly. VMT, how's it going? Where you been, my friend? It's been a while. But yeah, I hope everything's going well. How's the job going? And how's the summer been? So yeah, local and world space, basically. I've just reinvented local and world space. Yeah, classic. I've discovered something completely new. Yeah, and then it's not. But yeah, so then we unpack that. So this is for clipping and for drawing. We unpack that, apply it to the coordinate, your sample coordinate, for the world space one. And then for the local space one, we unpack it per shape, like a little matrix. It's all like just been thrown in here, just ignore that. And then we apply it. And it hasn't seemed to have affected any performance. Like, I think it was 0.6. It was 0.6, honestly, before we did this. MS. I partway did it, reduced it down to 0.58 ms for some reason. Then I put it fully and it was 0.6 ms again. So I want to check those VGPR things again and see and check what the stats are, because I need to see if it's like, well, it wouldn't have added any more VGPRs maybe. I don't think so, at least. Alright, the biggest shader. How many vector registers we got? 42. Oh no, it would have been scalar registers anyway. Because it's all done. They're all the same across all 64 threads, right? Or 32 threads, whatever. So it would just add more SGPRs. Hmm. Yeah, I thought it would have affected it a lot though, but it didn't. It literally did nothing. So I'm really happy about that then, because then we can literally do matrix multiply per shape. And which is pretty insane. I didn't think we could do that. We could be bound. I'm just trying to think how the shader is like what is the bottleneck right now? Are we bottlenecked on oh no, it's able to read the stuff out, no extra problem. It's weird. But yeah, we'll optimize it later. Try a larger one, 4x4. Oh, ours is 8x8. Yeah, we don't want to do 4x4. 4x4 would be worse performance because you're not filling in, you're not using a whole wave. Like the compute units are wave 32, and 4x4 is using half the waves. No, yeah, but it's because I changed the test scene there, code, so it's not dropped it by 0.3. I've just changed the scene, so it's different. Got less work. Hey there, Davros. Are all the game of an engine / write your own engine types taking a little pleasure seeing the Unity users squirm? So they're changing terms at the minute. Take it. Oh, a little pleasure. Sorry, I misread that. Yeah. I don't know. I've not seen the Unity news. Have the Unity guys changed their terms? Yeah, Unity just seems to keep going downhill. Like I think quite a lot of the people who came in to do the serious like Unity stuff to sort of take it to the next level, like the dots stuff and some other people in the actual like core engine team. I think quite a few of them left, like somewhat recently, like this year. So yeah, the engine has definitely reached peak. I wouldn't say it's I wouldn't say the peak was that great, but yeah. Yeah. Like I always take pleasure in just the fact that I get to sort of like write the code that I use, and then like if there's any problem with it, I can just dive in and figure it out. And have that control to do so, really. And it's also fun. Long live Coda, oh no. Is there a profiler that records your calls and stuff? In my head, I'm thinking of Unity Profiler, think VS, something like that. So currently I have a little mini profiler that we're running. This is simply there's a little extension in Vulkan which where it allows you to put in those little timestamps into the command buffer. So before you say dispatch, you go, I'll put in a timestamp there. Do your dispatch, and then you put in another timestamp. And then what you can do at the end of the frame is you can read back the timestamps that are waiting for you like 2 frames ago because it takes time. And you read them back. And then we basically just display them here in the terminal. But yeah, we've got a whole little profile API which allows us to read back these timestamps. I haven't done it CPU side yet. But yeah, we'll do one CPU side when we need one. It's all about the GPU right now. Because the GPU is what's going to give us like it's going to do all the cool graphics stuff, and that's going to scale at the resolution, right? So we'll see how well it does. Yeah. So we threw that in like pretty quick just to you know, throw it in like a stream, just so we can see all that stuff and not be flying blind, basically. I might be part of software world tightening up. It might be part of the software world tightening up in general. End of the up here. That probably applies to informal web companies, though. Right, Unity is probably still great value, even though they pay for more. But coding right from the ground up is much more satisfying. Yeah, that's right. That's right. Yeah, there's less. You know, there's still BS to. Like, if you program from the ground up, there's a lot of BS you have to deal with. But when you've dealt with it, like the operating systems I'm talking about, when you've dealt with that BS, you basically don't have to deal with it again until, like, the operating systems rarely update, and when they do, you can just deal with it then. Like, they're the most stable APIs. They're not the best APIs, just the most stable. So, you know, whereas if you have Unity or Unreal, those things update and you have to update your project. So, you know, and obviously you get, you know, as you develop the code that you wrote before to, you know, maybe wasn't the best and you want to refactor it, and that does happen. But you know, as you get to a point where you've been doing it for so long, you start to understand like this is just fine and you can just leave it and it does all the things you do. Copy paste it over, off you go. But yeah, right, I just need to take a quick break and get a nice fresh drink. But we've just discovered we can do matrices for basically free. So we're going to apply matrices everywhere, guys, and have some cool effects happening. So it's going to be proper sweet. So we'll be back in literally just a couple of minutes. Days, did I miss VMT's message? Sorry, VMT. I'll read your message. I did not see it. Apologies again. I'll read that when I get back. Right, welcome back, everybody. Right, let's read VMT's message. Right. Here and there, busy at work. Summer's been great, and I think I can pick up my new display tomorrow. Yeah, the one I mentioned. Yeah. Nice. Very cool. Sweet. Yeah, I know you mean I've been busy. I'm back at work now too. But yeah, and also looking after a new baby as well at the same time. But yeah, new display. That's proper sweet. Proper jelly. Get a nice 4K display. That'll be really cool. Yeah, I sent my display back and they just refunded me today. So I can now go and buy a new display. But yeah, I'm looking for one with like high contrast ratio, but I don't know if that's even possible without getting the Samsung one again, which is a shame. Yeah. So I code, I think translations might be useful here for things like dragging UI and windows or silly animations. Sounds like a thing to add. If it adds texture floats in the input data and you're not bound by input data for UI stuff. Yeah, so that means I'm doing 6 floats. So I could pack it down and then unpack, but that means more data. More CPU, I think. Or GPU, whatever. More compute. Or an OLED, but they got their own issues. Yeah, the OLED look cool, but yeah. Yeah, because right now I've got a 5,000 to 1 contrast ratio, so yeah, I don't know if yeah, it would just probably be a bit obvious for me switching to something different. But yeah, I'll have a more look around, I guess. You'll get rid of scale instead of really. Hmm. So the thing is about translate. For translate, you could just modify this, right? Every shape already has a position that goes in. Every shape. But then again, if you scale it, so that's the original position. But then all that scaling stuff doesn't get affected. Um, no, translate's always tacked on the end anyway, because it's scale, rotate, translate. So yeah, we could just apply it to the actual offset that you throw in, right? Does that seem more feasible? See, scaling, you can do non-uniform scaling though. You can scale across it's not uniform. So you can stretch things out in weird ways and make that sort of like UI that's sort of very cartoony, where it's sort of like slides and pops, right? Squishing, whatever it's called, that. Let's say you have a panel when you want to translate the whole panel, including every sub UI. So this is part of the draw API. So all it'll have to do is modify. Yeah, it's just part of the draw API. If you don't have wild translate, you will need to change the original position of every child UI. Yeah, but I'm wondering whether I need that in the... Like, at the end of the day, when you say I'm trying to draw this, I've got to make the draw commands anyway. Right, so what you're saying is it's in the matrix, then... Let's say if you have a panel and you translate the whole panel, every sub UI. Yeah, but you'll still have to recreate the draw commands anyway for those. Yeah, I just think the 2 extra floats just for translate. Yeah. So it's going to be like a media mode UI where you redraw everything, every frame anyway. So you'd be making a list of draws every frame. Anyway. Try to abstract parent translations into a uniform buffer, and you only update those when needed. Yeah, but ideally you want like a one per command. Right, I see what you're saying. Yeah. Right, so say if we modify this, you've got your... Let's have a think. Transform matrix. So the scale goes in... Get the images. So rotation affects all four of them. It's a 2x2 matrix, right? Rotation affects all four of them. Whereas scale just affects... Yeah, it's diagonal, yeah, but I'm wondering which way it is. Is it where the two ones go, isn't it? Because it's a vector, isn't it? So you're scaling the two directional vectors, isn't it? Yeah. Yeah, translate is the last column, but we don't have a translate. See, I think if we need a translate, do you need a translate? So if you have, say if you got this whole draw command, you scale it, so this thing stretches out across the x-axis for some reason. Then it gets rotated, so rotates it around a bit. Then it gets translated. Okay. So that's just... Right. So you're applying the translate to the coordinate, okay. So it's translate post scale, and you scale in that as well. In local. So when it's in local space, then you're scaling that. I'm trying to see if the translate's even useful, but I think it might be because it feeds in. If you're doing the world one, right, or the one for the bounding box, then you're doing the one for the local space one as well after it. Yeah, I need a 3x2. Yeah. Yeah, 3x2 matrix, but yeah. If I want to do translate as well. Hmm. Yeah. Right, I just had one more thought as well. We have to maintain the bounding box correctly as well. Because the bounding box is how we texture everything. Right, so let's have a quick play and make sure we got the matrix right. So let's just like scale it across the x-axis by 2 if that's right for the bounding boxes. So the bounding boxes will just be a bit bigger. Well, that was the y then. Wait a minute, or did that go the other way? Yeah, made them a bit wider. I think I need it to go the other way around. Because then I need to do the transform the other way around or something, because over me and now, we're back and now I've stood around. Good luck. Thank you so much. Appreciate it. Yeah, so I might have to do the inverse of what this is doing, basically. But I guess let's do the circle because it's probably a lot easier to see. So if we say make it 0.5, that stretches it across the x, or it should do. Yeah, see, it stretched those circles across the X. But that's by 2 times. It's pretty cool. But the thing is not stretch the bounding box. So that's where we've got to make sure we apply the matrix. So the problem is you've got to make the bounding box, apply the matrix to every corner, and then that will be your new bounding box. And the reason why we have to do the bounding box is because we texture it as well. So there's that. It's possible to do. Then we have the world space one that we also rotate and everything like this. Scale, rotate. So if you have the bounding box, so if you have this draw command bounding box, the question is if you sort of like rotate this thing, so you've rotated the bounding box. Right, so we could actually see this working. So where we do the implicit start, we can mess around with this. So we do a static float R for rotation, or whatever the angle. We'll just increase this to pi. So we say like R plus equal 0.1, and we'll say if R is greater than to 3.14, we'll reset that back to 0. Then you basically do like sine cosine type of thing. I always forget this. Yeah, so it's like cosine and negative sine. Okay, so let's try that. So you get F32S, which will be sine float 32R, and then C for cosine. So this one's cosine, cosine, negative sine, sine. So this is going to apply some rotation to every draw command. Now we'll look out for the texture, because I think that's going to get a bit buggered, isn't it? Well, I'm not seeing anything happen, so that's not good. Right, why am I not seeing anything happen? Did I get these wrong way around? Yes, I did, that's why. Draw matrix is the second one. Right, that didn't work. You've got your bounding box. We take you back to the center. Well, back to the origin, sorry. So the center is the middle of the box. We apply the transform. We translate it back. Oh, things are not using coordinate. Damn it. So it wouldn't have changed the... Shoot. Right, 2 seconds. Ignore these ones, these are the old ones we was doing. We can do skew as well, actually. I forgot about skew. Right, so these would be transformed coordinate. Oh, because we could leave it in regular coordinate, and that could fix it. Interesting. Maybe. So we left it regular coordinate for the texture. What does that do? um, right, I think we're messing... That's funny. We're messing with the... Is the matrix a little bit wrong? Like, what's going on? Um... Hmm. Well, we didn't actually test anything basic, did we? So should we just say, well, we've got R here, and then we'll put this back to 0, this to 0, and this to 1. See what happens. Right, so this just messes with the scale. And so if I put that to 2, all we really want is maybe 0. Let's say 0.9. Right, let's put that back to 1. Okay, so it's completely messed. Right, I wonder what we messed up then. Because we tried the matrix multiply on here, and that was fine. I think there might be another missing coord then. Right, so it loops around this thing twice. Once for clipping, second time for doing the coloring. We use transform coordinate. Right. If we're doing colors, it's using the draw one. If not, it's using the clip. I swap those around just in case for some reason. Right, because the clip one's not defined, so that was correct, the correct order. So we removed these. I'm pretty sure we need these, right? You rotate it back. Yeah, it doesn't work at all. That makes sense. So we can hardcode the values in. So this would be 1, 1, 0, 1, 0, right? Let's just double check that's all fine. Okay then. We found ourselves the problemo. So for some reason, this is... there's something up with it. Is it before or after the bounding box? It's before the clip command. Let's put this here because it would technically be better, but we'll probably remove it anyway. It's before the clip command. That's all fine because that all gets read okay. Draw words, allocate 4. Push 4 floats. So that's the matrix, right? I don't know what the problem is. So let's see if we can say D0, right? Just see if it's a problem with this array thing that we've got going on. 1, 2, 3. That would be weird, right? So this is D0. D1. Wait, did I say 3? I meant D2. Oh no, sorry. It's D3, isn't it? D3, D2. Right, so let's try that. Right, so reading it from the buffer, there's something wrong. I'll read it from the buffer then. So it's nothing to do with the array being the issue. So what I thought is the way it's ordered is you reserve enough for a bounding box. Oh my days, I know what's happening. The clip command is overwriting it. You bugger. Right, let's put the clip command in first. Excuse me. So when we finish the draw, what happens right here is we patch the draw commands access unbounding box, and then here we patch the draw commands clip command. So we was patching that and it was overwriting the matrix. Yeah. Cool. So that's fixed the problem. So now we go back to that matrix. Implicit start. So now we can apply R to this, or wait, it was S, oh no, it was C, negative S, C, I forgot, S and C. All right, let's try that. Super cool party going on. Right. So it's rotating crazy fast. So we put it 1/10 of the speed. Pretty jazzy. Cool, so what's wrong with our matrix? Let's change these negates. This goes the other way around. So let's change the sine and cosine around. So let's say there's sine. Thoughts on zig? I don't know. I don't care. Like, basically, all these new languages don't take, like, they replace C++, they don't replace C. They've got some good things going for them, don't mind you, but they just don't capture, like, what made C so great is the fact that it's not really, like, it's got some, like, features in it which you could literally take out and should be taken out, but it's basically quite simple language. And all these languages want to have this very complex thing, you know? And that's my opinion on all the languages. Basically. Yes. Why oh why? No worries. And also safety is you know, is too cool. It needs to be abolished. Unsafe is the way. See. Ah, come on, man. So what's going on here? What have we done? What have we done? Made something really funky, like really edgy advertising. We could do with this. What have we done with the Matrix? That's fine. So transforming that coordinate. Yup. Thoughts on Python? I don't know. Syntax is ugly. No types. People say you can program fast in Python, but I don't know. Do you really want to? Like, you can program the same speed in any other language. I don't understand it. Like, if a language has you're basically calling functions in Python that do stuff. Guess what? Every other language has functions. Like, that's it. Come on. What the crap is going on? What are we doing? So let's test make sure the scale's fine, right? Oh. We need to do the matrix multiply the other way around. Because what it's doing... Yeah, so it needs to be inverted. That's why. That is why. So how do you do a matrix multiply the other way around? That's the question. So instead we've got like our vector, and then we've got our... But then... And then we've got our matrix, right? So if we... But then that would produce... So it's this one times that one, plus this one times that one. Yeah, okay. Let's do this. So this one times that one. So that would be 0 times 0. So this makes the x coordinate, right, for your vector. This one. There's this one, which is this one here, times this one, which is this one here. Good. Then it's this one here, so it's the y, times 1, 0. Then this one here, so it's like the transpose of it, basically, I think. So in the y is this one, wait, y times, so y times, sorry, this one here I meant, is the x times 0, 1 plus y times 1, 1. Right. That ought to be good enough. So we've got to change all of the matrices. But okay, let's just do the draw one to show that it actually works. I think take all my zeros and ones out. All the workings out. Let's get rid of them. As you do. Oh, come on. What do we mess up? So let's bring it back to scales for a second. And then we'll see if we can fix it with something very basic. So let's just scale it across the x-axis by 1.5. Every draw command. Right, so that clearly didn't work. So all we did is we changed this around the other way around, right? So that didn't work. We need to figure out to do the inverse multiply. Is that right though? Oh, oh, good catch. Good catch there, not so red. Thank you. Right. So that looks like it's across the y-axis, is that? Right, so let's put that back to where we should be. Right, so this is where we want to be. Huh. It squished it inwards along the x-axis, which is not what we want. This is what we're trying to avoid, is it squishing. And I've swapped them around the other way and it appears to have done nothing. So squishing it in along the x-axis. So I want it to go the other way around, which I thought is why I could swap the, where obviously what it wants, if I do 1 divided by, then it would be what I want. So it's like the inverse multiply is what I want. How do you do that? Don't you just do it the other way around? Right, that's your inverse multiply. That's what I thought we just did. You just swap the order of the multipliers, right? Yeah, that's all it is. Right, so we had our workings out here. It's x. Yeah, we've just swapped the order, right? Then it's this one, that one, y times. Yeah, but how's that going to give us anything that we want? Hmm. Unless you use a divide, right? But is this even legit? How you would do it? Because I'm not sure how that would translate to like a... So if we did... Which way around would it be though? So it'd be that divided by 1.5, right? As an example. But then it's divided by 0. That ain't right. How do we get it to go the other way around? I swear you just swap the arguments and you do the matrix multiply the other way. I'm so confused. Matrix vector inverse. You want to go the other way around. If B is invertible, let... Yeah, you need to translate... Oh no. Yeah, so what I'm trying to do, I think the issue stems from the fact that when I do my matrix, it's scaling it the wrong way. Like I think it's because the way I'm working what I'm working around is... That's a good point. Why is it behaving this way? Yeah, so the issue is we've got a sample point. Imagine this is 0. We've got a sample point. If we say scale this by 2, the sample point is going up here, which is wrong because we want it to feel like the thing is going to grow. So to make it feel like the thing is going to grow, we actually move it in by half, right? So rather than making it scale by 2, I want to make it actually reduce by 2. So I could do this... I could do this by making the values go the other way around at CPU side. But I want to see if I can do an inverse and make it the other way around actually. It's just scaled the wrong way because the transforms are applied to the world. Green coordinates. Yeah. It applies Yeah, so it's doing it right. Um, so what I get is why does the it should move by a negative index. Yeah, I'm not sure what that means. What does that mean? Yeah, so if we scale it. To remove my workings out again. Right, so that's just shrunk everything, which is fine. That's what we... The scale's working okay. But then I guess if you want to do this rotation... Oh, the rotate just should work. Oh, maybe it shouldn't go over... Because pi is halfway, isn't it? No, it should be fine. But if it's row versus column edge, you should just swap these the other way around, but then it just makes it go the other way instead. Huh. Swap one of the S's and the C's. Okay, we'll try that. No. I don't know why that would work. The rotation is orthogonal. It wouldn't shear. Yeah, so it's doing that, right? Could it be the aspect ratio? Potentially. It's going really fast though, innit? Should we dim that down a bit? It's half it in speed. It's stretching out across the plane. Or is it? Yeah, it feels like it is. Well, we could just do a simple box. Well, we already do a simple box, right? That's the that is the background, right? At the bottom. 2.5. So the issue is the bounding box still. Yeah, and also, do you want to go to like negative pi to pi as well? Because if not, it kind of... Is that the reason why? And say if we scaled, I don't know. I feel like it's stretching. But the problem is the clipping, but it's clipping it obviously. But yeah, it stretches it really weird. You can see it here. Got a weird stretch going on. Let's double check my sinus sign. Pretty sure. Yeah. The maps are the right ones. Right. So if I did that 1 divided by again and inversed it. Nope. So what happens if we swapped these the other way around? Right, so it's not done anything there. Yeah, so we're rotating it back, or we're translating it back to the origin, back to the middle. And then we're applying the rotation. Yeah, I think the maths checks out because. But maybe this has to be S and C, like that or something. Oh, it just flips it the other way around, doesn't it? And that's rotate it around the other way. Oh no, you know what I'm doing? Can you see it? I'm updating X and I'm using X in the next line as part of the input to the Y. That's the problem. Fixed. Can you believe that? I could have spent hours on that, but I didn't. That'd have been bad. Oh, thankfully that was like just 10 minutes. Oh my days. So I do the same issue here then. Oh, I cannot believe I did that. Alright, shape matrix. Apply it here as well. Sweet. Right, that'll fix it. What's going on here? Can you just end, please? Uh-huh. Ta-da! Right, we got what we wanted. Rotating. Isn't she amazing? So, we're obviously rotating the wrong way, which is no biggie. It is simply just this negative s is the other way around, right? But anyway. Ta-da! So, that's cool. Now, why did we go and do that? That's the question, right? Why do we spend time to make that thing rotate? Because we wanted to test it out, right? And see whether if we could get this coordinate to be fine. And I think we have when we rotate it. And the reason why and how we've done it is we simply just didn't rotate the coordinate that was passed into... Oh no, we did. Okay, don't mind me. We used the transform coordinate. But when we use just the standard coordinate, what happens then? Then it stays still, and it's still... No, so the most silly thing is we've got a bit of a animation going on with the UV stuff, right? So we've got this sort of texture. That's the old code. I can't believe I've still got it in here. Texture UV. See, we've got this little animation going on. Where is it? UV bottom left. Right, so if we hard code that to 0, then it won't move. Sweet. So as you see, and it is literally just rotating, which is amazing. That's what we want. Thank you. Appreciate it. So that's all we want is that. Okay, so now we're going to get the bounding box, right? CPU side. So remember, we compute a bounding box, and that's why everything's clipping, because it's not inside the bounding box. So we should enable the bounding box debugging. Wait, should we do... We won't do stretching. Right. So the bounding box debugging is very, very great. There's a variable called yes. It makes it red. We need to kill the background, I think. Why isn't it compiling? Oh, okay. Sorry. We need to not render this guy. Cool. So here's our bounding boxes. So the bounding boxes need to be scaled now to account for all of this stretching and that, right, that's happening to these things. So how does one do that? So we've got two of them that we've got to handle. So at the end, we've got to apply the matrix to the AABB that we get at the end. But while we're building it, we've also got to apply the transform. Now we don't have a transform right now. Yeah, so we've got to apply it to each corner of each corner of the bounding box and then recompute the min max bounds, basically. That's what we've got to do. Now, how's this API gonna work? So there's two ways of transforming, right? One is the command, the other is the actual shape. So every shape could just take in a scale and rotation. Yeah. Okay. You ready for it? It was one of those problems that is a typo. And you could be scratching your head for hours, but we managed to luckily find it. So the problem is I initially had this, right? Where I was modifying X and then reusing it here. That's the problem. So in the matrix multiplier, so I've just fixed it. But yeah, so I saw it in the local instead, and I reused the old one here. Absolute head scratcher. Yep. But luckily we didn't spend hours trying to fix it. So we could take in a rotation, a scale along the X and Y, and then a skew. But why do you want a skew? What is a skew again? A skew is when you're applying it only in the top two, isn't it? No, you're applying it. Let's have a think. I forgot where these buggers go now. Or it's called a shear. So you just put it right. So it's the opposite diagonal to the scale one. All good. All good. Okay, so you could apply that on top. So I forgot which way around these things go. But anyway, so if we say, so the issue is there's a lot that goes in here, right? So what we might do is you can just say, so we'll keep the same API that we've got in a way, but rather than saying op, we'll say something like, I think we'll delete these ones from the clip. And we'll change the ones for the scale, rotate, translate, skew. Right. So we'll take these ones from the draw one and we'll just say in general. So you can do it for the clipping and you can do it for the draw. And this would just be like, it's not really just, it's kind of part of the draw API. So I can't really say UI. Damn it. It can be draw and, you know what, let's do it for both. But it won't be called op. And it does it for the next shape. Now the issue is you can do it for the whole command itself, right, for the whole thing. So we might say, we could say local, so you could say shape scale, shape this, shape that. What should we do? Shape, scale, or it could just be, it's kind of like, you know what? It's being shared. Let's do it. Shape, scale, and then you can do it per like command scale. That's it. Okay, good. So I'm not sure we need to translate anymore. We could put it on there and it might not actually have a difference. It might be fine. I've wasted an hour on on an equal instead of a double equal. Damn it. I wasted a whole day of my life this week because I copied old code and forgot to add a not condition. Yep. See, I get less and less of these things, but when they happen, Like they still happen occasionally. Like honestly, I rarely get them nowadays, but yeah, they still pop up. See, I'm not sure if I want to translate. It could be good though for the draw API type of thing as well. Should we chuck it in? It'd be an extra 2 floats. Honestly, I'm not sure what matrix this is, but let's just stick it in there. X, Y. Right, we got this. So we're going to be setting some form of state. And then every single time it just gets reset. So you could just have a matrix, right? But then the yeah, I think we'll just compute the matrix. Yeah, so we'll just say something like this. So we'll have them as separate commands. So we'll say something like, oh, you've got yourself a shape scale X, and you got yourself a shape scale Y. So that'll just be actually just this, right? Then, oh, you got yourself a shape rotation. And then you got yourself a shape translation. And then you got yourself a shape skew. Skew. Then you got yourself a command scale skew and all that. So separate components when you're using the API. And then, yeah. But then when it encodes it'll encode it into a matrix because it'll be more packed. We got this. Yeah, you can always do 4 equals x, that way the constant is on the left hand side. Yeah, I was recently told about that way actually. What song is the best one to listen to? Anything from Nick Johnston. This guy. Get a nice guitar on, nice bit of heavy metal. But yeah, I'll just do like, yeah, anything with like electric guitar, heavy metal, that sort of stuff. That's the best for me at least. Some people like EDM music, house, electronic, that sort of thing. All depends. Also anything from Stone Rebel. Stone Rebel's another one. We listen to that a lot on here. But yeah, that's my sort of jam. Yeah, exactly. You need to Yep. Not hardcore enough, that's it. Yeah, random song until you get fed up with it, then yeah, it sounds about right. So we've just gone and made a bunch of setters. Look at us go. I bet the OOP people are just like, you know, oh my days, he's using setters. Translate. Let's go. Skew. Oh, good. We're all good. Right, drop that in there. Drop that in there. Drop that in there. So these are all command. Okay, so now we've got these in here. So now all we have to do is have a way to compute a matrix, and voila. So where we do implicit start, this is, so we've got to do it in a few places, right? Because you got clip shapes and you've got draw shapes. We do SDFs, both basically the same AP, but we're doing 6 floats now. It's going to be insane. So 4 and 5 are literally just going to be G, UI. Okay, went quiet, that's fine. So this would be command translation .x and 5 would be .y. Right, so that's easy. So now the thing is, the way we've got to apply scaling and translating into the same thing, right? So usually you do like a matrix multiply to sort of combine the two things. Is that right? See, I'm not sure if it works. I'm not sure how it works. Like, so if you have rotation, you need to make a rotation matrix and a scale matrix, and you need to multiply them, right? Obviously, we can just do it manually. So the way we saw it is something like this, right? But then, so this would be like G UI dot command rotation. And then, you know, we should obviously set these all to identity. So that'd just be like 0. Let's just quickly do all that. Then it's skewing, isn't it? And then scale, obviously. Or I'm not sure what order they're in. It's things something like that. Right. Okay, good. So we're missing skew. So skew gets applied to this, like these two, and then you've also got scaling. You're a Polaris fan. Yeah, Polaris are really cool. I like Polaris. Although the guitarist died though. That's a real big killer. Yeah, Polaris are pretty sweet. They're really got really good guitar stuff. Really sad story. It's a bit like the architect, the guitarist in Architects died like a few, like, you know, it's been a while now. Similar sort of thing. CS, right, so I don't know if we need to multiply. Them together, you see. Or if there's an, like, because the way they make, so usually what you'd do, right, is you would say, okay, well, my scales just go here. So GUI dot scale X, and this is scale Y. Or they go in like the 0 and 3 column. And this would just be 0, because it's an identity matrix, right? So imagine if you've got to combine this one and this one. So you do that sort of like matrix multiply thing that we did earlier. But rather than just a vector, it's onto a... And I think if we translate this... So let's see if we can do this, right? Yeah, I want to do rotation and scaling in the same step. Can you just multiply them together, or is there something more complex you have to do? So you've got like S. So you've got your... And you've got to scale first. Well, you have to scale first, isn't it? So it's okay. Scale x 0 0 scale y. And then you want to do rotation negative s c c s, right? So that would get you Sx times c plus Sx times negative s. Yes, you have to do the transform, which is fine. We can do that. It's fine. And then you have to then apply... So the skew is going here. So what we could do... So what is skewing though? Skewing is... In what order does skew get applied? Let's call that shear, isn't it? What is shearing? Or skewing as we call it? Hey, Bernard Montana, how you doing? Welcome, welcome. Things going good, thank you. Yeah, we've just been doing some matrix stuff. What we've realized is we can fit a little... Well, we did a 2x2 matrix. But yeah, but we've made it now a 2x3 matrix. Yeah, we've just worked out that we're packing... We can put these things in and it doesn't really impact performance. So we're just putting in matrices now to do translations per shape and per command to get some fancy effects, some even more fancy effects. But yeah, how's things been going with you? How's the week going so far? Bum, bum, bum. I wonder, like, so the order is scale, rotation, translation, right? SRT. But where does the skew... Is that right? Yeah, because I wonder if you can chuck the shear into another one, or skew, whatever you want to call it. That's rotation, this is shear. That is scale by the looks of it. Huh, no, scale first. Why is this the other way around? M is magnification, S is shear. Right, okay. M is magnification, right. Too much maths. I'm good, but busy at work switching projects currently. Oh wow. Yeah, it's a lot to download switching projects. Yes. See, typically I work in a few little projects, but I guess you're switching like a whole big one, right? Or download all the new code into your brain. As long as you do shear before translate, it's good, right? True. Because the rotate, yes. Right, so that means I should just be able to chuck it in here. And do it all as part of this one multiply. Right. So, right, so here's your rotation vector, here's your skew and scale vector. What you're looking at doing is Sx times C. So to get the first column is Sx times C, right? Sx times C, Skx times S, Xks. Yes. Then the next one is Sx times S, right? This one times that one, this one, plus this one times that one. So then, so it's y, this one times that one, plus this one times that one. This one, wait, this one times that one. Oh, of course, it's just changing the y's around in it. Ta-da! I guess you can do the same maths and see what you end up with. Let me give it a spin. Awesome. Thank you. Projects of about half a year, yes. Nice. Is it a thing you're looking forward to? Like are you happy that you're changing projects? Are you kind of fed up with the one you've been on? And how you feeling about that? Yeah, because at work, obviously, you know, the game that I was working on has been end of service and been working on something new, and it was great being able to work on something new, basically, because I haven't released the game yet, and to be able to work on a game from the beginning and then take it to the end, it's gonna be quite interesting for me at least. Right, so this is the maths. Wait a minute, is that right? Yes, that's right. Sorry, I was just confused. Yeah, so this is column 0. So basically it's this, right? So Right, so let's just get into little floats. Sx equal this. So it's just nice and compact, you know. Y. Then sk. That's skew. Skew. And then you also want your little little rotations, right? Voila. All of the things you need. So all we need to do now is take this and put it in the right place. So there's your ones, there's your 0, there's your 1, there's your 2. Is that right? Oh, yeah, it should be, yeah. Very good. Right. Yeah, had a lot of smaller projects in parallel, and that was just exhausting. Not possible to focus, so focus again. Incredible. Yeah, I know what you mean. Context switching is hard sometimes. Radio, that should be it. Matrix multiplier, people. Isn't she amazing? So so that's only on the clipping, you see. So if we take this, we're going to move that over to draw implicit start. So that's where all the colors. So it's not the clip shape, right? It's just the proper one. And it's like, oh, reusable code. Here it is. Right. Cool. Right, what is next? We then need to take... Well, this is 6 words, isn't it? Then we need to take the... we also want to do this for every single shape as well. So this one just goes into the implicit shape start. Oh no, it doesn't. Per shape, isn't it? No. You just do it outside the if statement. Well, no. Right, I do think we need a function. So what we're going to do is we're going to say, I'll give you a stack and just put it all on there, reset it for me. We need it for the shape. So on the internals, can I get a shape transform? So you want to get back and make. Ooh. Matrix push. So you're pushing on a matrix for a shape. I think that's good enough. Thank you, not so red. Appreciate it. Yeah, that would have been one of those errors as well, wouldn't it? Where you just not. Yeah. Right, so rather than being command, this is shape. Scale needs to be 1 when it's reset. Which means also when we set the thing up, it needs to be 1. So when you say frame in it, we need to say, oh, by the way, GUI dot scale x equal 1. y. Yeah, it's also one of those areas which can like blow up my GPU and just crash the stream. I gotta be extra careful. So we need a stack. That's where the words go. Where do the words go? So shape circle. We're gonna be doing this a few times, right? So it's worthy to have a function. If it's just twice, no point really. Just copy paste code. It's more flexible that way. I've got the access line bounding box. Shape AAPB. Right. So still a few things we've got to sort out. So the matrix can get uploaded, that's fine. We've got to sort. Yes, that's all good now. The thing we have to keep note of is the fact that we've changed the size, right? So when we pull these matrices out now, we really need to right, so there are two I could just make them 6 floats, not gonna lie. Let's just make them 6 floats instead. So pull out 6 floats. Ooh. Right, so there's the clip transform coming out, clip matrix. So when we apply it, right, you've got, so I've got to be careful here now. So we added it in at 4 and 5, right? So at the end of the matrix was where the transform, the other one goes. So this can just be easy to remember. So 0, 1, 2, 3. And then basically what you do is you say add 4, add 5. I know it looks cryptic, but I thought it through, so it's fun. Oh my days. Right, so this is clip matrix. There we go. Cool. So that's how you apply a matrix now. So we just need to apply that per shape. So you apply the matrix here. This will be on diff. So shape matrix on diff. I could probably make that into a function, but also oh well. So shape matrix when it gets pulled in now, so let's make this proper. Shape matrix 6 floats. We could make a type. If we make a type, this can be reusable, but we'll do that afterwards. When we've got it all plugged in, we'll do a cleanup pass, and we'll do a special function which pulls out a whole matrix, and it would, and then I guess we can just have a matrix multiply that we'll do. Again, it's just a little custom one. It's no big deal. But yeah. Oh, did I miss making that 6? And then this one here. And voila. So that should be everything adjusted. We've changed them to both 6s, and we apply the 6s now. Awesome. We also have our new API, which allows us to do this stuff. But the problem is the bounding box still. But I want to just to show that it still works. So hopefully it doesn't crash the stream. We'll see. Okay. It doesn't crash the stream, but it's definitely crashed my heart. That was horrible, wasn't it? What I was seeing. So let's take a look at why. Clip and clip, that's fine. So let's see where else we do a matrix. You saw some force somewhere? Oh no. Yeah, that's fine. That's for the bounding box, that one's fine. One function, uh-oh. Right, so that one's okay. That was a good spot, guys. Thank you. Right, so that's definitely a problem. So I'm glad that didn't interpret the data wrong and crash the GPU. Right, so still buggered. See, I don't know why I really need this. Because it really could just take the number of words, take the end off, I think. Because I'm just adding... Like, because we do that for the clip shape. Like that. Should we get rid of this thing? Done. It's very error prone. Right, so this little local variable that we're going to make, u32, is going to be equal to core stack count of GUI.draw words. Take away the start index, and it's that simple. Voila. Ooh. Right, so still the same. We shouldn't have really removed that yet because it wasn't working, but oh well. Yeah, that's bad. That's bad. People don't ever do that. You just make problems worse, and we just did it. So we push on 6 words. onto the stack, that's fine. We could do a null matrix, just as a bit of a test, right? So if I record a thing, we can just say, right, duplicate all that, comment out these 6, and then say 1, 0, 0, 1, 0, 0. So looking for matrix, right? That was it. Good. Right, so looks fine. So it could be something wrong with the multiplication that we're doing in the shader, or it could be wrong with something that we're doing in the plus scale x, scale y. Sorry, not scale it. Sorry, translation x, translation y. So 0 times 1 times, that seems fine. I think it could be those sine and cosine things. There's a few multiply by zeros though. Could it be the skew that's messing us up? So if we just change, let's put this one back, and it's just going to break the shapes, right? Oh no, it doesn't. You're telling me this? Oh no, of course, because it gets set here. I think it's the skew. So if we put this to 1, maybe they should be 0. They are 0. That's fine. Unless these values are not 0 initialized because it got overwritten. Yeah, it should be, shouldn't it? Like, let's have a bit of a play, right? So if I did 0.5, it should scale across the x 2 times. Right, it's the inverse. Yeah, that's right. So if we did so if I did 0.5 here on this one, this should shear it. Yeah, there you go. Got a nice shear going on. So I think the matrix multiplication in the shader is fine. So we undid this. Why is this wrong? Well, we deleted our workings out, didn't we? So there's that. If we plug these in as 0, let's get my columns and rows right. So it's SC. Right, should we set this up again? Just double check. So we had like SX, SKY. Let's put that back. So scale X, skew X in one matrix with the Y here. Then I had my Or maybe I need to do it the other way around. So I think, yeah, so we'll double check that if this is right, we'll do the matrix multiply the other way around. There's C negative S, S, C. So we did this one times this one, yep, plus this one times that one. Well, I guess the negative S was here. That doesn't matter. As long as the other one is fine. Then we did, so then to get this one over here, so which is this guy, is Sx times this one, yep, plus Sky, X, sorry, times this one, good. This one is this one times this one, yep, plus this one times this one, yes. This one times this one, yep. This one times that one, yep. So I think that's fine. So I think we instead have to put them the other way around, which then should... So if you're doing it the other way around, this is SX, SKX. No, it's not. SKX, S... Oh, can you see what's wrong? It's not the other way around. I've been an absolute silly person. The skew and the scale were the wrong ones when I did the workings out. That's why. Right. So it was wrong. So it's instead these ones are wrong here. These bottom two. So the final two. So it's SKY times, and then, yeah, that's it. Booyah. So let's repeat that everywhere else. So just to double check, right? Oh no. Let's just repeat that everywhere else now. Ah, so good. Okay, so if we run that. Oh, terminals crashed, or whatever. The program's crashed and the terminal didn't want to close it. Okay, so we're at identity matrix and everything's looking good. Now. Oh, exactly. Beautiful. So what we have to do now is two things. We want to translate the bounding box, and we want to apply some form of transform and just see it happen, right? So we've got two different types of transforms. So we can have a play with one of them. Which one should we have a play with, right? So there's this one. Should we have a play with this one here? This nice gradient? Right, so we're going to rotate this bounding box around, and this AABB is the bounding... Sorry, no. The AABB shape inside here is going to get rotated, but the bounding box of the whole command isn't going to move, because we've got to fix that. So, where we have our bounding box... in the commands. So you got your wait, which one is it? That's the gradient linear, this guy. So this guy is going to get a shape rotate of 0. Okay, so we've got round radius divided by 50 times 3. So that would just basically rotate it the same as the way the gradient's being rotated down here. So rotate with the gradient. Well, it's going the other way. Why is it going the other way? Well, we fixed that. Right, let's fix those quickly. Sweet. Yes, the colors stay in the same place, which is what you want. So we're increasing the rotation, it rotates to the right. Fantastic. So, and it's in a smoothing, so there's two circles here, one here, and it's just rotating the box. Right, so, but the thing is, the edge isn't being rotated, isn't being adjusted, right? But let's just quickly have a bit of a play and make sure we've got it all good, because I want to make sure these things are perfect. Hey there, Sadra, how you doing? Right. So I want to make sure. So if we scale, let's say we scale across the x-axis. Now, I should probably make two functions for this, because this might be annoying. So we said 1.5 and then 0. It did make it bigger, didn't it? So if I said 0.5, that should make it smaller. That's good. Oh, that made it bigger. Oh, I did 0 on the Y, that's why. Scrub move. So we should probably assert if these things are 0. So, core debug assert amount.x. Something like that. I'm working on a small secret program for function plotting. I need a professional review of this. It would be very helpful if someone give me some recommendations how to improve that. Cool. Well, let's just take a little quick gander. Nice. So you want someone to review your little program? That's cool. Doesn't look too big. Have you seen we've got Discord? If you you know, if you get a spare minute, like if you go onto the Discord, go and join there. There's like a show your work section for programming, that sort of thing. I'm sure if you're asked nicely, like there's other people that can help other than me. But if I got a spare minute, I'll definitely take a look. It's just not really in the, you know, I don't really have a lot of time on stream to, you know, do it here is all. Hey, Sockham, how you doing? Exactly. We got extra good flags on, so you don't accidentally put a float inside a condition field. So we've reduced it here by 0.5. Can you see the box has got smaller? By half along the X. So that's fine. So what do we do? What do we do exactly? We said 1.5. Okay. So scale actually needs to become inversed. So you need to inverse it. How's it going? Hey, Stockholm. Hey, Bim. And the reason why is because when you put into relative coordinates, right, you have this coordinate point, right? I mean, when I say scale this by 2 times, it moves the coordinate point up to here. But this isn't going to give the illusion of the shape being 2 times as big, is it? It's going to give the illusion it's 2 times as small. So by doing the other way around and putting it here, it gives the illusion that it's 2 times as big, right? So that's why we invert the other way around. Cool. Should we try the translation? See, I'm not sure if we need to translate, not gonna lie. But we'll see. Should we see if this has messed with performance, actually? Right, so we try that one. That's increased it by 0.5 now. Sorry, 1.5. So we can do it across the Y and you'll be able to see. Increased it by 1.5. That's good. Compared to this one, see, it's, half as big. Very nice. So my question is, what's the performance like? So we bring back these guys and put it back to the state it was just quickly. We should be looking at 0.6 ms. Right, 0.623 ms. So we went up a little bit. I think that's manageable considering how much flexibility we've just added, right? We've added local space, translation, and world space transform and local space transform in, and it didn't really add a lot of crap to this. My one issue though is, would we need local space translation considering the shape itself is already got a position on the screen? But maybe it might be useful as part of the API. I don't know. I'm good. How's the progress UI today? Not doing bad. We've just been trying to add transforms in, and we found out that it didn't really add a lot of performance. Like, it added like about 30 microseconds in total, which isn't bad, all things considering. You could just negate the rotation instead of modifying the sine cosine. Yes, that is true. But yeah, it's one less negate, I guess. Because I just modified this. I just swapped this negate was already happening, but it was happening there instead. So I just did it the other way around, right? And that's all it was. Should we try a bit of skewing out? So let's see if the skew works. So let's bring back this thing here. So the next thing is skewing. So we skew across the y-axis. Axis, we'll be able to see it, right? So skew. Is that not a lot? Oh, that is a lot. See, I don't know how we want to skew. Do you want to skewing in? It's definitely skewing though. See, that's the problem. It's going to be skewing. Yeah. But also, I don't know how great this might be. Let's reduce the X a bit so we can see it. Hey, shouldn't I be seeing the red? So I've skewed the box. I was hoping that the box... They're skewing fine, I think. It's just I was hoping I would see it. It was take a simple box. Maybe we should skew the background. I was hoping to see it more of like... Here's the background. We'll make it a little bit smaller than the screen. And I'll see if that... Let's skew it by... Oh, okay. So on the x-axis, skewing it. This is not easy to see, is it? Let's disable everything else. Okay. It could just be the bounding box then. No, I think it's the bounding box. So you skew it. And I'm hoping to see the corners, you see, but I'm not because of the bounding box. That's fine then. Yeah, I guess we should test this out. And the skew might have to go the other way around. So I think you have to reverse the skew things as well. And this needs to be applied to this scale as well. Yeah, they're not applied to the bounding box yet. We need to do that. Definitely. We'll get to that very soon. I just wanted to test it out, you see, but I think it's fine now. So, should we apply the transforms to the bounding box? So I've already got some of the code, right? Basically, we should delete this. We should delete this. And then what we should do is we should take this code and we need to take the matrix. We need to have a way of taking the matrix and a point and getting that multiplied for us. And then we need to have this code which will recompute. So we need two new functions. We need a function to say matrix mul. So given a matrix, and given a point. So there's a point as well, yes, it gets the transform. Any one of them. And then I also need a way to say given this bounding box, can you recompute the new bounding box? Basically. So given a bounding box, can you recompute the new bounding box? So I guess I'll just say something like that. Bottom left that we mutate, and then I want a dims. Sweet. So what I would need to do is kind of take this code up here with us. Nice. So this is this code here, basically. This here needs to do the matrix multiply, UI shape, matrix multiply, matrix point. You say point equal this. So you take the existing corners, bottom left, so you pull those out, and then you get to work. Oh, it's doing like a top left, bottom right deal. Actually, I completely forgot about that. Because right now it's good in that form, whereas when it's in the shader, it's better in the other form. So you do your top right, take your bottom left, scale it down by half, that's your half dimensions. Then you take your bottom left and half dimensions, get your corners, go over all the corners, translate yourself a point, F32 times 2, F32 times 2, thank you. And then you re-min and max that to your bottom left, top right, and then you just at the end say bottom left like that, top right, top right. So that's how you transform your bounding box ranges. Is it correct? You probably then want to re-center it. So I think you want to then set BL to ABB center again, right? And then you set this to TR. So then you do the rotate of that bounding box and everything. Yeah, I think that makes sense. Very nice. So now just go get the matrix multiply. Where's that code? Well, that code is already available. It's basically this. So it's something like, oh, matrix, 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 right, then PT, 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 then return PT. Ta-da! Okay, so now we just have to actually use this function. And we use this where we have those shape circle. So see here how we do this sort of min-max onto this, and that's kind of not right just yet. So we need to make ourselves our bottom left. So it's bottom left equals this one. And you have yourself a top right, which is just the other way around. Then you want to apply that to it. So we need the matrix. Where's the matrix? So the problem is there's actually two matrices. Dun dun dun. There's a command. So it's at BL at top right. So there's two matrices. There's the local one, which you've just done, right? So this one should really return a pointer to that matrix that you've allocated here. Okay, no biggie, just as simple as that. So then you should be able to say, this is your local matrix. Now, the matrix that you done earlier, for the whole command, that one really needs to be stored in here somewhere. You kind of want to call it the command matrix. So when you start yourself a clip shape or a draw shape, that's the thing you set. So this will just be matrix, and then you also want to have the clip. So the issue is you're transforming those points again. It might be more performant to combine the matrices and then do it, but we can worry about that later on. Hey there, Psycode, how you doing? We decided to put the translate in, and all in all it added 30 microseconds, maybe 40 microseconds for the whole transform thing. But yeah, it's all going good. We're just getting in the rest of the code. Things are pretty close actually. But yeah, how's your evening been so far? So GUI dot command matrix. Now that needs to go first. And we also need to set it. So whenever we do some form of implicit start, Master Agent, how's it going? Thank you so much. Really appreciate the sub there. How you been? It's been a while. Is it working fine? Yes. Yes, I'm just fixing up the access line bounding box around all of the commands, but I've got a local, I've got a shape transform, and I've got a command transform. So it's looking good. Looking good. We've tested out a bit. It needs a bit more testing, but it's basically there. Right, so there's the other one. Sweet. So where we do shape circle, where's the clip one? Here we go. So this is what one we had with this. Cool. We need to do this sort of thing. So that would be draw words like that. Then this needs to be top right, bottom left. Just make sure we got that right. This one didn't change, so it's top right, bottom left. Top right, bottom left. Right, so we just gotta do the bounding box now. So we need to calculate that one. Add half size, sub half size. Now we take all of this and we take it down to our final one, which is the clip. Not the clip one, the draw one. And then that would be F32 matrix. Right. Oh, so that should basically be it. Oh, it's draw command. Damn it. Slight inconsistency there with the naming. So, right, so hopefully this should be it. Let's run the game. I have no game. Oh, it doesn't return a value. Why doesn't it return a value? Oh, return the matrix we've just allocated, please. Thank you. Right, clearly it's working. What did we bugger up? That is the thing. Expensive clear screen. That's all we need. Oh, damn it. So all we did is we changed the bounding boxes. So the bounding boxes are clearly wrong. So let's check them all out quickly. So we've got this clip words one right. It does. This is the circle, so that's the radius one. Sub to get the bottom left. Add to get the top right. Makes sense. You multiply the world one first, then the local. Is that right? Maybe that's the wrong way around. We'll sort that out. Sub the half size, add the half size, yep. Top right, bottom left, makes sense. Next one. Make sure that both, these are clip words here, they're clip words. Right, so that's the clipping shapes. These are the draw shapes. Bottom left is a sub, yep. Bottom left, top right, yep. Yep. Looking good to me. Right, so now we're going to look at this guy and make sure this one is all fine. So this one gets the bottom left. Top right take bottom left times 0.5. Add to get to your center. That's your top right. Okay, you get your different corners from the center. Reset this back to the middle. This is wrong here. This needs to be BL TR. And why is this adding it? Because the matrix multiplier already has that. Shoot, wait, what are we doing? You're rotating. Yeah, this is definitely really wrong. I think it's just point. Because you've got it in the place where you want it. Oh, right. No. So, I just realized. You're rotating it, so it's around the center of itself, isn't it? So if it's around the center of itself, point needs to be absent of. So this was right. So point needs to become this. And then this needs to be stripped of all of this. Something like that. Oh yeah. We did it. So, we did disable all the other drawing, not gonna lie. And this is the shear. I'm not sure if the box Hopefully that went right. So should we have a bit of a monkey around with the... So we've disabled everything for now. So there's the skew. So we could animate the rotate. Oh, it's all disabled. Right, let's just say it's rotated by 1. Right, so that's still not right, is it? Has it done it the other way around? Hmm. Work, lots of responsibilities in my personal life, nothing much except playing games when I'm not working. So don't go insane. Gotcha. What's the game you're playing right now? What's the game you would recommend playing? How's things yourself? No, I find like trouble playing a game where it requires me to think too much. You know, because I basically think all the time every day. So I want to just play a game that I can just be quite mind numbing for, you know. Um, Working on Game Van Engine, yes. Just been yeah, things been going good. Just been yeah, working on this basically in my spare time. Work is going great. The baby's doing good as well. He's proper cool. Like he's so much fun, you know. A lot of fun, that boy. Like, he's super cute. Um, nice. Is it also that framework? So I'm assuming you're making it all from the ground up. Basically, you know, it's got a few utility things. Like there's something for stack traces, which is like 400 lines of code. STB image. You know, probably use like microtar in the future. So it's all basically from scratch. Like even the GPU stuff. But yeah. Just yeah, compute shaders, you know. I just can't stop thinking. Yeah, it's one of them. You need to it's definitely a balance, because when you go too far, yeah, it can make you a bit mentally ill and just depressed. So you gotta tame that beast. I typically just exercise and just try not to think when I'm like, if you're working for a long period of time, try and stick to muscle memory as much as possible, basically. Oh, that won't work, will it? You said ABB center. Oh, no, that's fine. Putting it back to there, then you're re-minning and maxing it. It could be infinity, to be honest, but that just works just fine. The matrix multiplier is right, because that's the one we copied from the shader. It's up here. Yep. Um. Hmm. So should we start basic? Let's do a scale. And let's take it down to about 0.8 along the X. We'll just see what that does. You understand that the games I've been playing won't give you the rest of thinking unless you have no issues with losing progress or time. We're not being acutely aware of what's happening in the game. So Elite Dangerous is what I play. Better start playing Star Citizen. Nice. That box just got... What happened to that box, man? Right, so let's do nothing to the box. Yeah, I heard Star Citizen's actually got stuff now. But yeah, Elite Dangerous I've heard really good things about. Okay, so it is 0.8 on that scale. Oh. The problem is that it's the other way around. Damn it. So the problem is the matrix is going opposite. So we calculate the inverse of our matrix to translate the things the other way around. See, there's a way to do an inverse multiply. I just need to figure out a way to do it. Because then we can do it here. And call it inverse multiply. Just got to figure out a way to do it. I thought you just do this. No, right, is it? No. How does one do like an inverse multiply? So we could... So you basically you take the inverse of the matrix and then multiply. But you can probably shorthand the maths for that. Suppose compute not sure this is what I want. This is sort of what I want, right? But not to inverse the whole matrix, just invert the bit. I thought there's a way of doing it. Yeah, reverse of mate without using the inverse. Right, buckle up. You can use the Gaussian elimination, which involves ray reduction. Sorry, too much reading about arrays, eh? Ray reduction steps on an argumented matrix. This method works even when A is not invertible. Ooh. However, in case A is not invertible, the X vector need not be unique. And there can be infinite many solutions or no solutions if system is inconsistent. For example, matrix A1122 with vector 1, 2, then A is not invertible, the Gaussian yields Thank you. How do you get this? Yeah, how do you get it? Yeah, but how? But yeah, I've never heard about this. uh, it's a function for linear transforms. Oh yeah. Yeah, I'm not sure I'm gonna understand these things anyway. I want to do an inverse matrix multiply. Have you got any ideas, Psychode? So you know what I mean? It's like instead of inverting a matrix, can we just do an inverse multiply? I know there's a way to do it, but I just can't find it. Yeah, alien language. It just seems to be in C code, you know? You just inverse the matrix, right? Maybe there's not a way. Yeah, I'd have to inverse it. Or I can just write out two matrices, one for CPU, one for GPU. Jobs are good and the GPU one needs to be inversed because the way it works. Um, that's convention. That's not the same thing. Yeah, swapping them around the other way, that's row major, column major. That's what I was getting confused with earlier. When I tried to do it earlier. I can't believe this problem's biting me in the butt twice. I solved it by inverting it manually. Random quote, get physics serious using graphics programming, basically. It's fine. This is the way you can learn it as well, I guess. Right, that's pretty cool. Yeah, and the view. Yeah, I have to inverse this matrix because we're changing the coordinate. Yeah. Because we're changing the coordinate, right? So if you scale this coordinate, right? If you scale it by 2, it goes up to here, doesn't it? Right? But that makes this feel like it's shrinking, doesn't it? Whereas if you actually invert it so it halves it instead, then it makes it feel like all of the contents is growing, right? So as an example, if your sample point is here, and if you do the classic times by 2, actually we'll skip it entirely. And it'll make it seem like the shape is really small. Whereas if it's here, it makes it seem like it's really big instead. That's why we'll have to inverse it for the GPU, but for the CPU it wants it the other way around when we do the bounding box. I'm trying to think if there's a way around the inverse. I kind of maybe feel like either reinventing the wheel or but or slightly complicated stuff. So yeah, I was thinking about that as well. Like off stream, I was gonna think about this a little bit more the way I'm doing it as a retrospective. So we're currently doing it per shape. So we've got a shape transform, and we've got a shape transform so you can transform individual shapes, and we've got a command transform so you can transform the whole command. So that's not really projection view world though, or local. It's kind of its own thing. I guess there's multiple local spaces, right? There is a more local. This is like local space. This is local space. In a way, is that right? No, it is, isn't it? This is local space. This is world space. I think so. But yeah, maybe we should. Maybe we can make this sort of command matrix itself more usable in some way. I don't know. But yeah, what was I gonna say? Yeah, I think we've got a different problem than meshes though, because we're changing a sample point. It's different. Yeah, that is true. Object world matrix, ABB world matrix. Equal. Gotcha. Yeah. I understand that. It's just um the problem is inverse. Oh, why is it saying connected charge? Oh, okay, it's full. Right. Yeah, the problem is just inverse for some reason. And I can see it when I describe it as you're transforming a point. Um, right, maybe it's because it's in the shader. So the first one translates. Because I'm pushing into view space, is it? Yeah. Right, why is the problem inverse? So the problem is like, so the first one is like you've got your origin 0, 0 here for this one, and then you're applying them. So you got a relative coordinate, and then you're applying a matrix to that. sort of push into view space. Yeah, so like the problem is not so red. Remember, it's like we have to do the inverse. Like, so outside of CPU side, we don't have to do the inverse for some reason. So in the GPU, we are, say you have this draw command. You're changing the pixel coordinate, not transforming the actual objects, that's why. Yeah. Yeah, that's it. I'm transforming the pixel coordinate. So it's correct then. Whereas we're inside the... Whereas on the CPU side, we're transforming the vertices of the box and then recomputing the ABB. Yes. Well, no, I do have the inverse. I have the inverse matrix because of that, right? That works. But yeah, I didn't have the inverse now. It's CPU side. So the thing is, CPU side when I do this, where I calculate my bounding box, I need the proper matrix. Whereas inside, where I translate these corners to recompute the actual AABB of the command. Whereas in the shader, what I need is the inverse matrix because I'm translating the pixel coordinate, basically. So we might just maintain two different matrices. That makes sense. Yep. That'll be fine. So we just have to fix that problem. And then probably just let's just ensure everything is the way we want it with this transform stuff. So I think that'll be next stream. So making some good progress though. I'm glad we managed to discover that we could actually have two matrices, and it doesn't really cause too much of a performance issue on the GPU. So that was pretty cool. And we actually managed to do some maths today. Look at that. Oh, that was good. Right, so yeah, our next be on Thursday, 6:30 p.m. GMT +1. Wish I could help. No worries, thank you. Yeah, maths is hard. Never do maths on stream. I wish that could be true. There's Discord if you guys want to come and hang out. I usually post my updates on Twitter. Go and check those out as well. But yeah, that's about it. Oh, and also if you want to get access to the code, you can follow that link and take a look. You have to either be a Twitch sub or a Ko-Fi supporter. But yeah, let's raid Nico, my fellow pal who uses Unix. Okay, have a great next 2 days, guys. I'll see you on Thursday. Catch you later.